It says the vector is the vector to the right is 60 degrees east of south. So if we look between, okay, our vector is between east and south. Now we never say it's east-south. Okay, we say it's southeast. So the way that you would write it is south 60 degrees east. Now, if you were given this angle, okay, that would be, oops, a little off, that would be 30 degrees, this angle here. So say we weren't given the 60, okay, and you were given that that's 30 degrees right there. You would have to find that this is 60 and then write it south 60 east, because it has to be in relation to that north-south line. Okay, we're going to practice that a little bit more. If we do something called a true bearing, if you write a true bearing, I think those tend to be a little bit easier. It is the angle measured clockwise from the north vector. So if you start north, okay, you just look at what is the degree measure from here to where my vector stops. Okay, well, obviously this is how many degrees? 90 degrees. Okay, so from here to here, that's 90. And so then right here, how much is from my 90 to my 60 right there? That's 30 degrees, okay, because this is 60. So if we do 90 plus 30, that's 120. So your true bearing is 120 degrees. That's kind of how we go about this. So we're going to do some practice here together. Leave him a little off. There it goes. Okay. So I'm going to help you label. So in that left-hand column where you can draw something, I would highly suggest drawing a quadrant, okay, and then we're going to do true bearing. I'm going to kind of show you and kind of help you label things. On your quadrant bearing, it's important that you label north, northeast, south, and west, because you have to have the direction in a quadrant bearing. And then for true, it's important that you have the angles here, okay? We know this is 0 degrees, okay? We're going to label that here at 0 degrees, but with a true bearing, it's written with 3 digits, okay? So this would be 0, 0, 0. Okay, this is going to be 0, 9, 0 because that's 90 degrees. What's going to be my 1 all the way to 5? 180. Okay, and this guy is going to be 270. Then if we were to go back to the start, that would also be 360 up there. Okay, so you can keep that in mind. That's also 360. You don't have to label that. But. So when you write a true bearing, it's always going to be with 3 digits. Okay, so I want you to remember quadrant, okay? This is going to be an acute angle, okay? It's always going to be small. It's going to be a small angle. And it's from that north-south line. So if we look at number 1, okay, this is 85 degrees here. Is that to the north-south line? Like, is this angle touching this line here? No. Okay, so the way that we would name it is by this small angle, because that is the angle that's touching that north-south line. You tracking with me so far? Okay. How many degrees is my little angle there? 5, because this one was 85. Okay, so that's 5 degrees. So we know for quadrant we're going to do the direction. So this is north, this is east. So the way that we write it is we write it north 5 degrees, because that's how far we are from the north-south line, east. So whatever 2 sections your vector is between, that's going to be your direction. So for example, we were between north and east, it's going to be northeast. Questions on that? Okay, so, and again with true bearing, okay, we're doing clockwise from our north-south line. So up here, okay, or up here I should say, we go 5 degrees, so it's going to be 0, 0, wow, 5. Okay, and we write it as 3 digits. This next one's a little tough just to find the angle that we're talking about, because we're going to want this angle right here, because this is the one that is going to touch that north-south line. Okay, I want you to see if you can find that measuring. Just problem solve, see if you can figure it out. If this helps you, I think they should have drawn this right here. Okay, has anybody got it? What do you think, Ethan?
58.
58. How'd you get 58?
90 plus 90 is 180. And then 180 plus 32 is 112. I subtracted 32 from 90.
I gotcha. Okay, so what I would do is I would say, okay, this whole thing is how many degrees? Circle. 360, right? So I'm going to subtract 212 from 360. With me there? Okay, that takes out this whole section. So you get rid of that if we subtract 212. The only other section we need to subtract is right here, which is how many degrees? 90. So you would do 360 minus 212 minus 90, and you get 50 degrees. Okay, so that is that angle right there. Okay, so when we talk about acute angle, okay, we're working with that 58. So, what is going to be my first letter that comes here? South, right? Because it's between south and west. So south, 58 degrees west. Okay. True bearing. Okay, so our true bearing is the degrees from north. Okay, so if we're from north, okay, we want to figure out how many degrees is that until we get here. Okay, how would I figure out that degrees? Say it again. 180 plus 58. Anybody have a different way of finding it? There's another way to find it. That would be a little bit more complicated. So we do here 90, and here 58. Okay, so if we add those together, we get 180. Go and grab that. 238. You guys get 238? Okay, so that would be our true bearing, 238 degrees. They're right over here. Okay, number 3. Okay, this one's a little different because it's pointed to the left. Good news is that when we talk about a quadrant bearing, it's already the angle between the north-south line in the vector. Okay, so that one's pretty easy. So we know we're going to have 24 degrees here. What's going to be our first direction? North. Okay, and then west will be our second. So north, 24, west. I want you to see if you can find the true bearing. See if you can try and find that true bearing. Hint. Okay, we start here. We go clockwise. Okay, what'd you get? 36? Yeah, because 360 minus 24? 336. Okay. Do we want more practice with this before we move on to word problems? You feel okay? Okay. I was a little worried about that just because it can get a little bit crazy when we throw word problems. But we'll see how we do. All right, so an airplane is flying at a bearing of 245 degrees at 550 miles per hour. Okay, so that would kind of be like, we would say that 550 is the magnitude. Okay, that would be kind of when we talk about like the distance of our vector. So if we were to draw that, that would be like the distance. Give the velocity of the airplane as a vector in component form. So let's go ahead and draw this first. Okay, I always draw it. It makes life a little bit easier. If they're giving you degrees, like they're giving you 245, that's a true bearing. So if we were to go 245, let's see, that would be 180. This is 270, so like, I don't know, there. Okay, so that is 245 degrees. Now, because we're not in quadrant 1, we have to do a little changing of an angle here. So you have to trust me on this process. Okay? You're going to want to know this formula. Okay, it's 90 plus the quantity 360 minus your angle. A is your angle. Okay, because we're not in quadrant 1, we have to use this formula. And I would just put that in your calculator. So we plug in 245 because that's our angle that was in our problem. Okay, I'm getting 205. Okay, so once we have that, 205 is the new angle that we're going to use in our formula. Okay, so if you have to change it, use that new angle. Okay, we're going to use this guy right here because we're writing it in component form. Okay, and we have the magnitude and we have the angle. So we're going to go ahead and put that in component form. So our magnitude is 550. So we'll have 550 times the cosine of 205. And then 550 times the sine of 205. Now, is 205 on our unit circle? Anybody know? It's not, okay? If it was, we could use the unit circle, but we can't. Good news, kind of, because we can just put it in our calculator. Oops. You can just put it right in our calculator, and we'll get a decimal. Okay, so we have, oh man. Negative 384. Oh, I'm probably not in degree mode. Yep. Check that calculator, make sure you're in degree mode. Let's try that again. All right, negative 498 point, we'll say 5. It's fine. You're not doing decimal places. If you round it 2, I'm not picky on that. That's totally fine. And then we'll go ahead and do our sign. Negative 232.4. So if we were to name that vector, okay, we would name it by writing that right over here. So that's what you would name the component form of that vector, kind of being on the beach. Now, what I want you to notice is the signs on our numbers. They are both negative. Does that make sense as to where our vector is pointing? Yes, right? Look at this. It's pointing into quadrant 3, so it should be double negatives. You can always kind of check your work that way, make sure everything kind of lines up. Okay, questions for me? All right, next one. All right, if a man pushes a lawnmower with a force of 25 pounds uphill at an angle of 40 degrees, give the force exerted on the lawnmower as a vector in component form. Okay, so let's go ahead and draw this. Whew. Okay, so when you're doing these problems, think about it realistically. Okay, if they give you 40 degrees, but he's pushing it up a hill, we're not talking there. That doesn't make any sense, right? Like, he doesn't push the lawnmower this direction. So we push a lawnmower on flat ground. Let's redraw that whole thing. So here's what this would look like. Okay, they're saying this is your 40 degrees because he's pushing it this direction. So you kind of have to think about what's going on in the problem. Let's draw it realistically. So when we do our component form, okay, our magnitude or our force in this case is 25. So we'll do 25 cosine 40. 25 sine 40. Because we're in quadrant 1, we don't have to change any angles. We're good to go. So there's our component form for that. Questions for me? Okay, so our last one on this page, we have a cruise ship is sailing at 20 knots in the direction. So when I say 20 knots, that's again going to be your magnitude of north 12 degrees west. So now we're not given just a regular angle, we're given that quadrant form. So we need to draw that out. So we know north is here, west is here, so it's going to be somewhere in this direction. And if it's 12 degrees, do I go 12 degrees from here or 12 degrees from here? What do you think? This one, right? North-south line. We always go from there. So we're going to go right here. Okay, and that's probably a little big, but that's okay. We'll call that 12 degrees. Okay, now we're going to write the linear combination form with I and J. You have to find the component form to be able to do that. It's just another way of writing it. So whenever you see linear combination, don't get intimidated. We're going to do the same thing we've been doing. At the end, we'll just write it into a different form. Okay, questions so far on that one? Okay, now because we are in a different quadrant, we're going to have to do our 90 plus 360 minus 12. Ooh, actually, I don't think we can do 12 because that's not the, rewind on that. Okay, we have to find the true angle. That has to be our true angle. So if that's 12, what's our true angle going to be? 360 minus 12? 348. So you have to have that as your true angle when you put that in. All right, we put that in our calculator. $102. So that's the angle we're going to use in our component form. So we have 20 knots times the cosine of 102 and 20 sine of 102. That's our component form. We do have to put it into linear combination form, so we'll do that in just a second. But I want you to check our answer, make sure we're good. We have negative positive, which is in quadrant 2. Is our vector in quadrant 2? Yeah. We're good to go. So if you write it into a linear combination form, we would say negative 4.2i plus 19.6j. I think I'm going to save the next ones for tomorrow, but I want to do some bearings practice. So you guys, if you want to write stuff down, you can, but I just kind of want to walk through doing these together because we're going to need to know, like you guys are going to have to be able to do this inside and out when it comes to the picking out the different angles. Okay, so if we do, you can choose to write this if you want to, you do not have to. If we look at this first one, okay, if I want the quadrant, okay, if I'm going to write it with the quadrant, I'm between north and east, okay, and this one's nice because it's already from that north-south line, okay, so what is going to come first? North, 30 degrees, east. Good, that one was easy, okay, and then our true, what's our true? Huh? It's just 30, because it's the degree from that north spot. So in this case, it's just. Ooh, I guess we'd have to write it as 0, 3, 0. So we have to write it with 3. Okay, so that one was decently easy. See what we have next. Okay, so we have. This is 73. Okay. So if we're trying to do quadrant, do you remember where the quadrant has to come from? Does it have to come from the north-south line? Or can we just use 73? Has to be north-south line. Okay? So the good way to think about it is both of them do, really. Because true comes from the north, and then quadrant is from the north-south line. So you always have to be from that reference point. So if this is 73, what's this measurement over here? Huh? 27. 90 minus 73, 27. Okay? So for our quadrant angle, we're going to be north 27 east. Tracking with me on that? Oh yeah, that would make 80. Yep, sorry. Thank you. So north 17 east. Oh. What's our true? How far from north? 17. So 0, 1, 7, 0. Okay. Oh. Here we go. Okay. Okay, quadrant. Are we ready to go? Do we need to rewrite anything? Do we have an angle that's coming from the north-south line? Yes, right? Because this right here, there's our north-south line. It's coming straight from there. So we don't have to find anything, which is nice. So this is the south. This is the west. So it'll be south 34 west. Oops, I degrees in the wrong place. Okay, so our true, we're going to have to solve here. How am I going to find my true bearing? Say it louder. Yeah, 180 because we're starting from here. So it's 180 plus 34 would be 214. So 214 degrees. Okay, so we have 12. Okay, good. I like this one. So quadrant, are we ready to go? Can we just use 12? No, we have to find it from that north-south line. So you're going to go here. So you always go that shortest distance. Remember, it's an acute angle. What's my distance there? Yep. 78. So I'm going to be, what's my first direction? North. Good, because it's pointing north. 78 west. All right, my true bearing. So I would do 270, right? 90, 90, 90, plus 12 would be, you guys feel better about that? You feel good? Think you can do this? Okay. So when we get to the word problems, you have to do this, and then you have to solve the problem. So I want to make sure. All right. Rest of the period, we'll finish those. Well, we won't finish it next part, but we'll continue this tomorrow.